Okay, you guys, it's AP Calculus AB, and this is my warning video. I know that the pass rate, the national pass rate on the AP Calculus exam is extremely low, and there are some reasons for that, and because there are some, if not tricks, some catches that we're supposed to be aware of. So as we're aware of those things, we really increase our scores. So here's one right here. We're looking at these two functions. We're going to find the area of the region bounded by f of x is equal to the opposite of x cubed plus 6. G of x is equal to 0, and on the interval -2 to 2. So let's kind of start this by doing just a little bit of scratch work. One is we want to find out where the zeros are of this function. The zeros happen to also be the intersections of the two functions. So if we set that up, x cubed plus 6x is equal to 0, and we solve, we get negative x times x squared minus 6 equals 0. X is equal to 0. X is equal to plus or minus square root of 6. So we know here, so here are these intersections that we have. And the question is, one of the questions is, do we have to deal with all of them? So here are these intersections here. And remember that we're interested in this interval right here. So what I want to know is this inside of that interval or not? Well, the square root of 6 is, right, square root of 4, square root of 5, square root of 6, square root of 9. This is, I'm just showing you how I'm getting my math here, is between 2 and 3, isn't it? So here's -3 out here, so it's not here. I mean, right, it's in here somewhere, so here's our -2. So that's good news for us. We don't have to deal with that. So the area we're looking for is here, and this is square root of 6 out here, isn't it? This is this is the opposite square root of 6. So square root of 6 is bigger than 2, so 2 is somewhere in here, isn't it? Just to give us an idea of what it is we're actually looking for. So that's what we're looking for. All right, we're looking for this area plus this area. Okay, so these are the two areas that we're looking for. And we're going to accumulate those two areas. This is what I also know, and I'm really concerned about here, is part of the little trap for us, is that we know we have symmetry here. And well, I can tell you before we even do any math here, if it makes you feel any better, I can tell you that the area, that if we take this definite integral from here to here, if I set this up, this is what they're hoping you're going to do. They're hoping you have your calculator in front of you, or even better, that you just look at this and go, okay, the definite integral from -2 to 2 of f of x dx, just to simplify. And then you go, oh, you know what? Whatever this negative value is, this is the same positive value, so it nets to 0. Well, it does net to 0. And if on the exam they said to you, find the definite integral from -2 to 2 of this, given these boundaries, the net area would be 0. However, we know, and we have to remind ourselves, that in the case of the AP exam, every time they say area, they mean the absolute value. So this is what we're going to find out here in a minute. We're going to find out that this is -8 here, and that this is +8 here. So our answer should be area equals 16, right? Right, just area addition here. So we take the absolute area of this plus the absolute area of that. However, if we fall into their trap and we add these two numbers, we're going to get area equals 0. And that's one of the answers they're going to provide to you. And they're providing that answer to you as a distractor in hopes that you'll screw this up. So let's just make sure that we don't, okay? All right. So again, if they ask you for a definite integral, that could be negative. If they ask you for net area, that could be negative. On the AP exam, they do not use the term net area. But if they ask you for the definite integral of something, the definite integral of this interval is 0, but it's not the area. So that's our warning today, okay? So from here, this is what you have to figure out. You have to figure out which function is on top of which at which in each interval. So g of x is this function. Isn't it true that from this point here to this point right here, from -2 to 0, g of x is on top, isn't it? And f of x is on the bottom. It's down here, isn't it? So we just set up our interval. We say, all right, our integral says that from -2 to 0, we have our top function as g of x, which happens to be g of x is equal to 0, right? Minus the function at the bottom, which happens to be opposite x cubed plus 6x, isn't it? Right? dx plus, now hopefully you're going to see what's happening here. It's going to change the sign of this. Some people just put a negative out in front of the sign of the integration sign, which is fine, but this explains why it's true. And then we're going to go from 0 to positive 2, and if you look from 0 to positive 2, f of x is at the top, isn't it? And g of x down here is at the bottom, isn't it? To get this place. So I'm going to take that, and I'm going to say that from 0 to 2, what we really have is negative x cubed plus 6x minus the other function, and the other function was 0, wasn't it? Dx, right? From here, we can start simplifying, and it gets really good. This is a note I made to myself as I prepared to talk about this with you. Please, if you're on the free response part, why get killed for bad notation? So make sure you're using good notation. I see a lot of people, they forget to put their dx's here. It's really important, and they're going to take a little piece off, and at some point there's 1 point that separates you from your score to a 4 from a 5, and I want you to get the best score you can get. So please, good notation, okay? All right. So we can go ahead and simplify this out really quickly. So let's simplify. And that, if we simplify this, we distribute this inside, we'll get positive x cubed minus 6x dx, right? From negative 2 to 0. I was complaining to you about good notation. I almost screwed it up myself. Sorry. And then the next interval is a definite interval from 0 to 2. And we make sure that we have the whole thing covered after all of our intervals. And we have x cubed plus 6x minus 0, of course, doesn't change anything. So that's where we're going to go from there. Oops, sorry. I'm going to close that whole thing up. Good. So you can see better. Right from here, we're ready to integrate, aren't we? So we're going to go ahead and integrate, right? Remember, our goal is to integrate and evaluate, and we evaluate using the fundamental theorem of calculus. Okay, so I'm going to take the integral of this, which is x to the 4th over 4 minus 6x squared over 2, right? Just want to show it to you, which happens to be minus 3x, right? And we're taking that from negative 2 to 0. We drop the dx, we drop the integration signs, because this integration sign is our promise that we're going to integrate. We did it. So when we complete our promise to integrate, we drop the integration sign, right? So we have that. Look, this is 3x squared, just so I don't want to confuse anybody, right? This plus sign is this one, and we're going to now integrate this, which gives us negative x to the 4th over 4 plus, right, 6x squared over 2, so 3x squared, doesn't it? And we have to finish our interval, so from 0 to 2. All right? So you could go on with this if you wanted to, but I'm not going to. If you can hear bells ringing behind me. We're not going to go through this. But now we're going to apply the fundamental theorem of calculus, which states that the area is f of b minus f of a, and we'd have to do that twice. And the area should be 16. All right? Let me know how this works out for you. And please, 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 remember, I'm warning you. I'm trying to help you that this is a kind of a setup for us, and we have to be able to do our best to get past this. So please, please, please make some note to yourself. If there's any question you have of me, please contact me at Lindelof Videos, or just make a comment. You guys are great. This exam's coming up, so let's make sure we crush it.